everyone. Thank you all for joining us today. Sorry about the delay. We had a few technical difficulties, but we're excited to see you all here today. The Harvard Undergraduate Art History Society and the Astronomy Society are excited to welcome you to our first ever collaboration. And this is one we hope will spark further cross-disciplinary conversations in this space, pun intended. My name is Marion Gray. I'm president of the Art History Society and former aspiring astrophysicist turned aspiring art historian, thanks to Professor Roberts, who is here with us today. And I'll be moderating today's discussion with Ariel Frommer.
Awesome. Yeah. Hi, everyone. I'm Ariel. I'm the president of the Harvard Undergraduate Astronomy Society. And similar but opposite to Marion, I came into Harvard thinking I was going to study art history, but I've since turned to astrophysics. And now I'm planning to pursue a PhD in astronomy next year at University of Wisconsin-Madison when I graduate. But I've really remained very interested in art history in my time here. For example, I work at the Harvard Art Museums as a tour guide. And in fact, both Marion and I were super lucky to take an incredible course exploring the art and science of the moon with Professor Jennifer Roberts, who we're super excited to have today as a panelist. The class's aim of engaging with astronomical objects and ideas through an art historical perspective is really what inspired us to put together this panel.
So before we dive in with our panelists, let's rewind just a little bit to remind ourselves how we got here and what is particular to astronomy in the 21st century. So some 400 years ago, it was Kepler who defined astronomy by the visual, asserting in a pre-telescopic paradigm that astronomical hypotheses must ultimately be subjugated to the domain of observable appearances and optical laws. But astronomy naturally has experienced many a sea change since Kepler, and today astronomy can explore elements of the cosmos that we can't even observe with our own eyes. We have things like X-ray and radio astronomy, gravitational waves from black holes, and lots of fancy particle detectors that detect exotic subatomic particles like neutrinos that are passing through the Earth every second. But still, somehow, the primacy of visuality persists in forms like the dazzling images from the Hubble and Webb telescopes that I'm sure you're all familiar with, for which we assign in many ways arbitrarily visual coordinates for invisible data. So today we'll get to hear perspectives from science, art, imaging, and art history to learn more about the processes and stakes of these images. But first, I'll turn it back over to Ariel for some logistics for the webinar.
Yeah, so we really hope this panel will feel more like a conversation between our panelists. So I'm just going to do some brief introductions, and then we'll head straight into our questions for around 20 to 30 minutes. Then we'll take questions from the audience. But before we dive right in, I'm just going to take a few minutes to briefly introduce our wonderful panelists. So first, we have Professor Jennifer Roberts. Jennifer Roberts is an art historian and professor of history of art and architecture at Harvard, whose work aims to challenge the binary divisions that are assumed to exist between the humanities and the sciences. She is outlining, among many other research projects, a new book project on space imaging and the reciprocity of art and astrophysics. We also have Joe T. Pasquale. Joe D. Pasquale is the principal science visuals developer in the Office of Public Outreach at the Space Telescope Science Institute in Baltimore. Joe's work requires a unique blend of science, art, and photography to bring data from the Hubble and James Webb Space Telescopes to life in high-quality, colorful views of the cosmos. We also have Jack Madden joining us. Jack Madden is an astrophysicist, artist, and research affiliate with Blue Marble Space Institute of Science. After getting a PhD modeling life on other planets, he went on to get an MFA in digital media from the Rhode Island School of Design. He is currently exploring new ways of seeing the universe through its image artifacts, romantic era inspirations, glitches, and military connections. And then finally, we have Philippe Riquet. Philippe Riquet is the outreach manager at the Harvard College Observatory, part of the Harvard Smithsonian Center for Astrophysics, where he organizes a variety of science outreach initiatives, such as public observatory nights, STEM fairs, and hands-on engagement activities for people of all ages. Passionate about science communication, Philippe crafts engaging narratives that inspire curiosity and critical thinking while amplifying underrepresented voices in STEM. So now that you've all been introduced, we can start with the first question from Marion.
All right, so as you probably guessed, one reason that we wanted to host this panel jointly between the Undergraduate Astronomy and Art History Societies, and with panelists, of course, from a range of backgrounds, science, art history, is that we hope in some way to sort of shout across the void between STEM and the humanities. So an initial question for all of our panelists is, what do you think stands to be lost in the split between science and art? And what do you think there's to be gained by collaborating? Let's start with Joe, if you will.
Oh yeah, put me on the spot.
Sorry about that.
That's all right. So what is there to be lost by not engaging? I'm sorry, that was the,
Right.
okay. So I think what would be lost is that there is a connection. There's definitely a connection between science and art. If you ask most scientists, they will tell you that there's definitely a connection. The processes, the mental processes involved in pursuing science are very much linked to what it's like to be an artist and to engage with, the visual, to engage with the world in a way, seeing things in a different way. There's definitely links between the two. And so I think it's only natural to pursue those connections. And what is lost is there's a whole world out there. The connections really bring people together. I think growing up, people are taught that science and art are very separate things. And if you don't show people early on in life that these two things are very related to each other, then you kind of send people down different paths. And they may not necessarily think that they're even cut out to be a scientist or cut out to be an artist, depending on where their interests lie. So I think it's very important to pursue those connections.
Amazing, thank you. Jack, would you like to continue the conversation?
Yeah, I think Joe's completely right. I think the humanities and sciences are kind of our best ways and best processes to understand the human experience and then the natural experience. And so as just humans experiencing nature all the time, we need both forms to have a complete understanding of the truth of the universe. And that separation can crop up when you try to kind of romanticize each or simplify the fields as not processes done by scientists or done by artists, but as science or art, as like a separate thing that's just separate from the human. And yeah, you get into trouble when you try to simplify it like that. But it's always has been and always will be human experiences.
Absolutely.
So should we just dive in?
Go for it.
First, I just want to say I'm just so honored to be here with all of you and have a chance to talk to everyone else on the panel. And thanks to Maren and Ariel for setting this up. This is a question that, as someone really coming from the art history side of things, I've thought a lot about. And I think one of the problems with the way science and art are understood in a general sense is that they're seen to be a binary. In other words, science and art are understood to somehow occupy completely opposite sides of some, continuum of meaning and knowledge, and that they compensate for each other. And so often when you hear people talk about science and art working together, it's like bringing in an artist to sort of bring in the opposite, bring in the subjective to the objective, for example. And subjectivity and objectivity is a really common binary that's used to separate the two. But in fact, I'm really interested in thinking about how we can break those binaries down altogether and find other ways of talking about the relationship between these modes of understanding. Subjectivity is not specific to the arts and objectivity is not specific to the sciences. And these two modes of thinking weave themselves through everything that scientists and artists do. So I like to think about other ways of talking about the kind of capacities of both sides of this seeming divide. So both science and art, I think, are about detection. They're both about very close attentive observation. They're both about attention. And they both produce observations that overturn the status quo and provide totally new ways of thinking about life in the universe. So there are so many ways that these two fields seem to me to be almost sort of synonymous in a lot of ways.
That's so great, thank you. Philippe, would you like to finish us off with this question?
Yeah, sure. Hi, everyone. Hi. Yeah, so I guess my take on it is that I think science and art are incredibly important to work together because they see the world and the universe in two different perspectives. And so there's a lot to lose if we separate them, but there's so much to like, for example, the human connection to the stars and inspiring a diverse group of people. But there's so much to gain as well if we work together. And I actually have a great example. There's here where I work at the Center for Astrophysics, we have a we have a very talented musician who's he's a musical composer. He specifically creates science-themed musical symphonies, and he takes real data from the universe, like data from black holes and data from galaxies, and he translates that into musical symphonies. And so he has a very good one called the Black Hole Symphony. And so something like that is fantastic, and it's a great way of attracting different types of audiences, because you don't just attract people who are interested in science, but you also attract people who are interested in the arts, like music.
Yeah, that's all wonderful. I think for the second question, this is primarily for Joe and Jack, but of course everyone is welcome to chime in. But we wanted to just ask, what actually is the process of creating an astronomical image look like for you? How do you extract a signal from the limiting effects of noise? And for maybe non-astronomers out there, noise is just random or unpredictable fluctuations that can obscure patterns in the data that we want to see.
Jack, I'll jump in here.
Go for it, Joe.
Okay. So I just wanted to jump back for a second to something Jennifer said about the distinction between subjectivity and objectivity. I oftentimes give talks about how these images are put together, right? And I usually have it sort of broken in half, where the first half is the objective part of the work, which is gathering the data, cleaning the data, running the data through data pipelines that gets rid of artifacts and makes it the cleanest version possible of that image. And then it moves into the subjective part. After you've cleaned the images, you've stretched them. So I'm already starting to talk about the process, right? And it moves from this objective world into a more subjective world, where we have to make decisions about the color composition of the image, the tonality, the overall look of the image, including its composition, its orientation on the screen or on paper, cropping, things like that. And that's where like the eye of photography kind of comes into play here, because you're thinking about the overall look of the image and how things play off of each other. What are like the visual cues in this image that will, how will someone's eye follow features in the image, that kind of thing. So it really does blend the two together. And it's funny that you brought those two things up, because they go together kind of seamlessly as I'm working through an image, but I oftentimes, when I'm talking about it, I think about them very separately. Yeah.
Yeah. Although I think what I meant really was that there are plenty of artists who will have whose artwork also involves an objective part and a subjective part, conceptual art, or any number of projects where artists are also kind of observing and then working with what's essentially data. So that's all I meant was, I'm not saying there is no distinction between the two, but more just that we can't so easily separate them into this camp of scientists and artists.
Yeah, exactly. And then to get back to the question a little bit, pulling signal out of the data, ideally, the images that we make that are the most impactful, those are images where we've designed the observations to be to provide us with the highest signal to noise that we can possibly get. So, we sit on an object for a very long time and gather as many photons as we can and create a really clean, rich image. It's when we have to do sort of like the science releases where scientists have proposed for time on the telescope, and their main concern is, addressing their science goals. And sometimes they don't need all that data. And so they get what they need out of it. And then we are left with what's left there to make a beautiful image out of that. And that can be a challenge sometimes, pulling the image out of the data.
Mm-hmm. Mm-hmm.
And I'll kind of add in this whole other side of space imaging, which not many people get to see. But if you flip through like a science journal in astronomy, it's not just full of web images in their highest composition. It's a lot of graphs and data tables. And I think if we want to kind of advance this intersection between humanities and science and images for astronomy, it's important to also think about like the graph as a designed object that it is appearing most in the science that gets done, whether it's a spectrum, which a lot of James Webb time is devoted to gathering a spectrum, which isn't a pretty picture, but it's just a graph of how the light is behaving in a certain area, and how that kind of gets translated and reinterpreted and passed along to non-experts kind of through this graphical nature, whether that's having to make up an image to represent the finding, or just kind of presenting it raw and having a scientist explain in detail like what each of the little bumps mean.
Yeah. I don't want to dominate the conversation, but since Jack just brought up spectroscopy, that is something that we think about a lot in our press release imagery. We actually put a lot of work into creating an overall look and feel for spectroscopy products because, as Jack alluded to, spectroscopy is actually like 80% of the observing time on the Webb telescope. It's really mostly spectroscopy and not all of the beautiful imagery. And a lot of that spectroscopy is for like extrasolar planets. And so we have graphic designers who will build these, beautiful artist impressions of what a extrasolar planet may look like, and that will serve as the backdrop for the data, which is the featured part of the image. And it's presented in a way that's we try to make it as accessible as possible. Instead of having like flux units on the y-axis, it'll just say like brightness, right? Dimmer, brighter. The x-axis may just be time. In fact, when we did the very first release of observations from Webb, the spectroscopy components, the time axis was actually time in Baltimore in like Eastern time.
Yeah,
I think one of the things to keep in mind here too is that even though graphical representation is not like a photographic image, it is still very much a visualization of data that is beyond the visible. And so it's still it's still a way of bringing information from outside of the human sensorium and then sort of stuffing it back into the body through the eyeballs, right? So it is, I consider these as sort of they're all images in my mind. That's the way I would talk about them, but there are very big differences in the kinds of habits that these two different kinds of images trigger in viewers that is important to keep in mind.
Yeah, I think this gets at a really interesting idea, which is that scientific data is often not expressed through like the simple visual images that maybe the public sees. There's like this very unique visual language for the kind of plots and graphs that appear in scientific papers. And so kind of as a follow-up question that we had, maybe as an image scientist, but also all the panelists, please feel free to chime in on this question. How do you feel about the balance between true visuals and having images rather that convey scientific data? And do you find that the visuals created for the public are less scientifically useful, or do they still have value in that way?
I can go first. Yeah, I think it has an immense amounts of value, and I definitely think that editing and then like doing color enhancements on certain astronomy photographs is definitely justified when if you're dealing with the public, because that is really like, for example, my job is to really get people inspired about the wonders of the universe, and so if I do edit anything or color enhance any photography or any science images, I'm very transparent about it, and sometimes I can use it for a bit of a wow factor, and so. An example that I have actually is this little guy behind me, this little red scope. It's a new toy we just recently acquired, and I put that there on purpose because it is something that it's a bit of a cheat in astronomy, that it can take these amazing photographs of the night sky, but it's kind of like cheating because this whole thing is fully automated, and then I can take these images which require very little training whatsoever, and then I can enhance them, and then I can distribute them through members of the public who visit, for example, public observatory nights that we hold here at the CFA. And so I do think this is quite empowering as well. So yeah, that's a thought that I have to share.
I'll just say that I've had many times now where images that I've put together for a press release for the public, the scientists involved in that press release loved the image so much that they actually wanted to use it in the paper. And they'll like swap out an image from their paper with the public image. So it definitely still has scientific value, even if it's, the main goal is to deliver it to the public.
Amazing, thank you. And just sort of as a follow-up to all of these thoughts that are being pulled out here, What are ways that in creating these visuals, you might compromise accuracy or realism to make something more visually clear or potentially more visually stunning to the public? So what do you think about potentially compromising for aesthetics, especially in this space where you're arbitrarily assigning things to things that don't exist in the visual sphere on their own?
I mean, I'll say from my experience, I think the biggest compromise is the stretch of the data. I mentioned this earlier. Stretching is basically brightening the image, right? Telescopes have a very sensitive dynamic range, so they're picking up the dimmest light possible all the way to the brightest objects in the universe and everything in between. But usually what that means is that the image is essentially a black square when you first open it, and you have to adjust the pixel values in that image to be able to see what's in it. And that right there is taking the data and it's manipulating the data in a certain way to pull out all the detail that's there. I tend to think of it as, we're just revealing what's already there. We're not changing anything. That data was captured by the telescope and we're just trying to access it. It's kind of hidden down in the darkest regions of the image. So I guess, I don't really think of it as a compromise, but we are stretching the data beyond anything that your eyes could ever see. Our eyes just are not sensitive to light in the way that a telescope's vision is. So, if you want to call it a compromise, I would say that would be the compromise, is pulling as much detail out of the data as possible.
I guess to follow on from this red telescope, one compromise that I have is this telescope doesn't actually have an eyepiece. It is something that you look at the night sky through an app on your mobile phone. And so no one's actually seeing with their own eyes what you're looking at in the night sky. And so that is the biggest compromise. But at the same time, these are incredibly accessible. And so you can have anyone take their own astro photographs themselves through a smartphone and an app. And so to me, for public engagement, the compromise is justified for getting people excited about space science.
Yeah, I'm really glad that you brought up this notion of accessibility, because ultimately, what's less accessible than space, really, for a human? So putting that down into an accessible scale is a really wonderful thing to think about, especially in your position as you interface with the public.
I wonder too about, even 20 years ago, I imagine that the public had less familiarity with just the basic idea of sort of stretching light values in an image than they do now, because everyone has these filters on their phones. You can take a photograph, play with the exposure, play with the contrast. So people are maybe a little bit more familiar with simply the idea of bringing certain kinds of data out of even their everyday photographs. And I wondered whether you have found that people are less concerned about these filtering operations in the scientific space now.
I would say based on just reading comments on social media,
Yeah.
which is not really a good metric for anything, but people do there's a lot of people out there who just assume that images from NASA are CGI, like we're just making it up. And so, I feel like it's my mission in life is it's as often as I can to go out and give talks about how the images are actually put together and talk about the process and show, from the very raw data that comes to from the telescope to the finished product, what every step of the process looks like. Hopefully it's changing minds, one mind at a time, but I don't know.
That's something I wanted to add to is once these images are created, they can be used anywhere in any context. And I've had images that I've made used as the cover photo for a journal article about a completely different topic. And then people think that that's a real image of, whatever they're studying. So yeah, it's a jungle out there for space images. And yeah, no matter how hard we try to keep a wrangle on it or put context around it, yeah, anything can happen, and it's a challenge that I struggle with a lot and is very frustrating. I don't have a good solution for it yet.
Yeah, that and the question of, is this what it would look like if I could somehow go there and see it with my own eyes, right? No. But there's a reason why, right? Like telescopes, we design these instruments to broaden our view, to give us, superhuman vision to see the universe in new ways. I like to make the analogy to, if you've ever been to a dark sky location and you see the Milky Way, the Milky Way is an amazing galaxy that we live in, and it's filled with light and color. If you use an instrument to look at it, even a camera can capture that if you take a long enough exposure, but our eyes can't see that. So, flying out to an object somewhere to look at it with your own eyes really doesn't matter. Don't be hung up on your own eyes. They're very limited.
It's such
It's a kind of non-human vision,
Sorry, Jennifer. Do you
Go
want
ahead.
to? I was just going to add, it's such a good point about the human eyes. We recently did an event here where we were trying to find a comet. It was the Atlas. I can't pronounce the last part of it, but the comet that visited us in, when was it? In October, November last year. And we all looked up and we could barely see anything. Everyone was very disappointed. And we used the telescopes, and still everyone was very disappointed. But then we had this one fancy telescope that could take a long exposure of the comet. And then suddenly everyone was exposed to this like absolutely stunning photograph of this comet that was above us. And so good example of how our eyes can sometimes be pretty poor at what we're trying to see in the night sky. And sometimes having a handy gadget can be far more impactful.
Yes, this is all wonderful. So I just wanted to flag, we had a few technical difficulties, but we've been able to bring our last panelist onto the call. We're so sorry about all of the issues, but Mark Robinson is here now. So I think I'm just going to do a brief introduction, and then I'll ask the first question again for you and kind of tell you a little bit about what we've been talking about, and then we can kind of keep going. So Mark Robinson, who's joining us today, is a lunar scientist with Intuitive Machines in Phoenix, and was a professor with the Arizona State University School of Earth and Space Exploration for 18 years before retiring in 2024. And he's currently the principal investigator of the NASA Lunar Reconnaissance Orbiter camera, which has been orbiting the moon since 2009. So yeah, we've been talking a bit about imagery and astronomy and thinking about ways of processing data into forming images. And so the kind of question that we had first posed was, what is your process of creating an astronomical image, and how do you think about extracting a signal from the limiting effects of noise? And yeah, feel free for others to chime in again. We're sorry again about the technical difficulties.
Oh, I'm sorry. The solution was so obvious. I should have just logged on with another email.
No worries at all. These things get complicated.
Like a total knucklehead.
Well, we're happy you're joining us.
Sorry about that. It's silly. Yeah, why don't you guys start talking, and then I'll get into the swing of things here.
Yeah, okay.
Yeah, okay, so we'll jump into our next question, and then Mark, if you have anything to add, you're more than welcome. So pivoting a little bit from the conversation to this point, and focusing a little more again on process. So what are some points of connection that you might see between astronomy and art history that may emerge when we consider specifically how scholars or scientists are using different tools and techniques to actually analyze these visual images and the data? I know, Professor Roberts, you mentioned at the beginning that the process of distilling this information into some sort of a visual format is part of the interpretation, and there's a lot to be said about the connection between art history and science as far as observation and the sustained engagement with observation as a form of scientific discovery. So we'd love to hear perspectives from both of our art historians and our scientists on this one.
Well, I think one of the things that art historians do is they think a lot about various kinds of visual conventions, and how even the simplest photographic image is itself a very specific kind of visual language, that we can think about the sort of habits that it inspires, what kind of metaphors do different kinds of images bring along with them. And so, I mean, something that's really interesting to me about space imaging in the kind of photograph or pseudo photographic mode is the way, like, let's imagine an image in our head that Joe made, let's say the cosmic cliffs. You did that one, right? Yes. Okay. Let's think about the cosmic cliffs for a minute, or anything that's coming out of the web visualization program, I feel is being received in the mode of photography and the way people would approach a photograph on Earth. Those habits of vision are being brought to these images as well. And there are just a lot of really interesting kind of assumptions that come along with that, and certain things that come along with the format. So a photograph is always, by definition, a kind of an image that's, it has a boundary around it. It decontextualizes to some extent what's inside it. So for example, that image of the cosmic cliffs, which is part of a bubble near the Carina Nebula, I decided, well, where exactly is that? I can't orient myself to this object. So I ended up chasing down a series of websites to try to find where that comes from in the sky and how I would ever see it if I looked up from the Earth. And so the idea of a photograph, it inherently takes certain kinds of information away, even as it adds information. And something that I think a lot about as well is that when we see a photograph on Earth, there's this assumption of instantaneity, that the shutter was, opened, and then the subject of the photograph was right in front of it, and everything was together at the same time. But with virtually any space image, that is not the case, because the light that you're seeing is coming from, 8,000 light years away. So photographic images, I think about them as encouraging certain kinds of interpretation that might actually not reflect the science, because the science of that cosmic cliff is that it's 8,000 light years away, and that light left that space, during the Neolithic period. And that photograph is 8,000 light years long. So I wonder about how the kinds of visual formats that we use carry so many other kinds of meanings along with them. And how do we make those work to bring out the science that we want to show?
I could talk a little bit to this. The images that we take with, spacecraft in orbit around a planet are very different than an astronomical image in many ways, right? And one of my favorite things that I get to do as the PI is think about an image that I want to take when the lighting is right and the spacecraft is in the correct position. So I think of that as landscape photography. It goes back a long tradition of some of the earliest photographs, and like Carlton Watkins and the American West and so on and so forth. And for instance, like there was this one picture that I wanted to get of Giordano Bruno crater on the moon at an angle looking at it like 60 degrees, because when you look straight down on a planet, it's very different. It's an unusual perspective for most people to try to interpret that image. But if you look off of the side, that's like an astronaut looking at the window, and it's much more spectacular. But the lighting has to be in a certain to convey either a feeling or a scientific return. We talk about incidence, emission, and phase angles in science, but a lot of it is also the feeling that the image is going to give you. And so Sir Isaac Newton is in control of the orbit, right? So we fly over at a certain period of time. So you have to predict that way out into the future. You have to predict what the lighting is going to be. And then we're going at 1,600 meters per second relative to the ground. So there's exquisite timing that has to take place to get the image so that what you want to image is centered in the field of view. And then there's different kinds of distortion that is in the image just due to inherent to the system. So you have to process it. But we've been doing this for 16 years almost, so 15 years and 9 months. And every day I still have that feeling when I come in and I can download a picture. And my first impression of it is an emotional. And then after that, it's like, oh yeah, look at the phase angle on that. And look how these units behave differently in that kind of lighting relative to earlier lighting, right? So that's very different than an astronomical image, where you, like you just so eloquently stated, it's something that's many, many light years away. And that happened, what you're seeing happened a long time ago. And what we see on the moon, and since we've been there for 16 years, we're now finding craters that formed during the lifetime of the mission. right? So these are kind of immediate. I know I've been talking a lot. I just kind of stepped in right now. And I'm really excited about, you know, the comparison of, you know, taking astronomical images, planetary images, and bringing them into the context of art history. A lot of people push back on that. It's, and, you know, I've been kind of, you know, we like to use the word fighting, but, you know, I've been trying to work with art history community for 20 years to get more recognition, that so what if I didn't push the, you know, the shutter. I commanded it. It was 2 weeks before the image was taken, but Andy Warhol didn't make any of those paintings, right? He had a crew of talented artisans that made them, right? So, you know, it's just kind of put some thoughts out there, a little difference between the planetary images and the astronomical images.
Absolutely. Those are great insights. Thank you, Mark.
Call me if you want to talk to an art historian.
I'll do that.
I'm
Yeah.
very interested in this. And I think too, something else, I think one of the reasons maybe that it's hard to see, it's hard for some people to see, say, lunar, like orbital imagery as art is that the just immense difficulty of getting these photographs is not always evident when you see the final product. I mean, the narrative that you just gave us of all of the calculations and the trajectories and the orbits and getting the light right and hitting everything at just the right moment, and not to mention getting a still photograph when the camera is moving that fast, is such a exquisite artistic sort of filigree of activity that that somehow doesn't remain in the, as obvious in the image as it might. I mean, something that I'm very interested in is how do we kind of, how can we show your work better? There's so much emphasis on a beautiful final image that is it's hard to get a sense of all the artistry and the scientific difficulty as well that went into it. Like how do you attach that to the image is a big question of mine.
I think it's connecting with the right people, right? And, you know, we've had a lot of, in fact, we had a giant show in there, National Air and Space Museum, that I consider it a photography art show. But in one sense, it's not quite so true at Air and Space Museum, but you're kind of preaching to the choir, right? In one sense, because there's a lot of the people that go into the Air and Space Museum have some cognizance of, you know, how spacecraft images formed and so on and so forth. But I've had several art shows in galleries in downtown Phoenix here where it was the exact opposite. People had no clue. And I'm telling you, some of the best times, best talk I've had about the images were in art galleries where we had the images up, because then I could relate what you're actually seeing, how this came to be and what you're looking at. And, you know, there's things like on the moon, there's no atmosphere. So you don't have a sense of scale. I mean, one of the ways our brain processes that something is far away, I mean, our stereo only works out about 10 meters with our, you know, your vision. If there's a mountain range over there, one of the reasons that you know it's far away is it's blurry because of the atmosphere. And the Apollo astronauts had that problem when they were walking towards an object in the distance. What they thought was nearby, it wasn't. There's a famous story in Apollo 16 where John Young had kept walking and it kept going further and further away, and the rock kept getting bigger and bigger and bigger until they realized it was bigger than a house. Because he had no sense, you don't have a sense of scale. And I showed someone a picture of a mountain on the moon that's 9,000 meters tall. That's 30,000 feet tall, right? And it's like, how do you process that as a human being? That's great. I'm sorry, I get all excited when I start talking about lunar image.
No, that's so wonderful. Thank you. And actually, Professor Roberts, I wanted to make this follow-up question to you because I've heard you speak so eloquently on this before. But so we're talking about things that are missing in the image, whether it's scale or a more accurate sense of temporality or the work behind it. But my question is, so what's at stake in that image? So how do the visuals that we see influence our perception of and maybe our responsibility to space?
Yeah, I mean, this is something I've been thinking a lot about, and I'd also very much like to hear what everyone else has to say about it, but I guess I'll just say I've been thinking about a couple of things that are hard to see in a lot of space imaging. One of them is the distance between us and the object. That seems to me a really fundamental aspect of the universe that people should think about, but it's hard to see that. Like how, so one question would just be, how can we make that more visible? How do we convey that through imagery? That's the kind of really difficult cognitive visual problem that is an artistic problem as much as anything else. So there's that. And then the other thing I've been thinking a lot about is how do we convey that we are immersed in the universe? We're not just standing on objects separated by truly empty space. There is really not any such thing as totally empty space. We've got plasma, you've got cosmic stuff happening all over the place, and there's a sort of medium that we're all immersed in that I also feel I want to be able to understand visually, but is hard to sometimes in space imaging. So for me, the stakes in this is that I'm concerned about how a lot of rhetoric around the space sciences, really space politics right now, has to do with ideas about occupation and conquest. We should occupy Mars, we should colonize Mars. And there's a sense that the outer space is a kind of something out there outside of us that we're not actually a part of. I mean, it doesn't make sense to occupy Mars because we kind of already occupy the system in which Mars exists. It occupies us and we occupy it. We are immersed in space. It's not something to go out and conquer. So that's one of the stakes for me. And the other one is just, again, how do we wrestle with the difficulty and the distance of all of these objects that we're envisioning? They're not proximate. We can't have them. So I think I would like, for me, it's about how do we convey, and I think part of this is about showing your work. I mean, it's like, I love reading Joe's blog where he explains how these images are made. Like, I'm really fascinated by all the stuff that has to get out of the way in order to make the final image. I feel like that in some ways that's kind of the universe. There's knowledge in that too. So I really want to see it. I wish there was some way we could just attach your blog to each image as kind of metadata. I'll leave it at that.
Yeah, I wish we could do that.
Yeah.
Yeah, this question of what's at stake and what is missing. There is, in almost every press release we put out, there's the main image, and then there's usually what we call a compass image that gives some contextual information to what you're looking at. Mm-hmm. And that's where, to the best that we can, we try to show our work a little bit. It includes the number of filters that were used to make that image and how they were colored. So they're color coded according to, how they were put together to create the image. There's usually a scale bar involved that gives you some sense of, how big is this region of space. It doesn't necessarily mean anything to people sometimes because it's a scale bar usually in arc seconds and then in light years. So even understanding a light year, right? Like, I don't know how many people know that a light year is 6 trillion miles, right? Trying to put it in terms that right, familiar with, is very difficult. It's really hard. And then beyond that, sort of like more philosophically, what's at stake is that, we are looking at the universe. We are the universe trying to understand itself. When we look at nebulas, stars that have exploded, these are populations of stars that have seeded the universe with heavier elements, which then lead to the formation of planets like ours, where the elements that make us up were at some point created in a star. So coming at these images with that understanding, I don't know how often people actually do that, but I think it really helps give you a new perspective on them when you do that.
Yeah, this question of what is at stake in these images can keep me up at night sometimes. I think a lot about this, having transitioned from a scientist to an artist, to kind of dig deeper into what these images are doing to the way we perceive the universe and how that kind of trickles down through all the systems that we have. Because I think about kind of humanity and the way that it creates meaning as a really important way to think about how we view space. And you know, throughout history, the way that civilizations have connected to their understanding of the universe has been a really dominant and powerful force in creating all of their systems. You can think of religions kind of centering around universe theories, even like an existential will to power, kind of a nihilistic sense, can shape civilizations and countries. Even just the way that we think of resources on our globe as a way of interacting with the universe at large. And I wish I kind of knew how influential these images were in kind of shaping that, as maybe someone's first experience of the universe is through an image, like a Hubble image. And what that kind of, what the style of those images kind of sets up, what the conversation leads to, how much deeper do they go into those images? I know probably very few people after seeing an image like goes on to become an astronomer and really truly understand like all of these different elements of the scale and the distance and what's outside the frame. So yeah, what is happening there in shaping kind of our current society through how we understand the universe through web images is a very, very fascinating question. I don't think Joe can answer it. And I think it's great that we're having a conversation like this just to even consider kind of that deeper question.
I think it can be really potent to think about the power that these images have on people and have on humanity. And this kind of leads really nicely into our last question. But we also just want to remind the audience that we're going to take audience Q&A. So feel free to start popping those questions into the Q&A. But going to sort of thinking about the power that these images can have, do you all remember the first space image you saw, or at least one, you know, that made an impact on you? And sort of, yeah, if so, what was it? And what sort of impact did it have on you?
I can go first.
Please.
We're probably going to have some of us might have the same answer, but for me, it's got to be the Hubble Deep Field. When that image was released, it kind of blew my socks off, really. And then also the pale blue dot and the caption by Carl Sagan is, I think, one of the most powerful captions attached to an image from the universe. And when I saw these images, yeah, they just kind of blew my mind. And I think that I remember that really inspiring me to get into astronomy and space science.
Amazing, thank you. Mark, do you have it? Thanks.
Yeah, it's not a specific image, but it's a series of images. I'm old enough that, you know, as a kid, I saw the very first planetary images that came back from the Mariner missions, but it was really to some degree, the Mercury and Gemini images of the Earth and of the astronauts. But really, I think the image that made the biggest impression to me was a really awful video live from the moon during Apollo 8 mission when the first humans orbited another planet. See, I was 9 years old. Yeah, 9 years old, right? And it's just like, it was just, I ran out to the mailbox, you know, that week that the Life magazine was supposed to show up, which is probably none of you know what that is. It was a monthly magazine. And during the Apollo, Mercury, Gemini, and Apollo, they always had spreads of, you know, pictures that astronauts took. And so that's really, I had, you know, collections of those magazines. And you know, so that really, I'm sure I'm sitting right here on this panel because of those images. And you know, when I went to my first degree was art and photography. So somehow I went, I don't know how I got where I'm sitting right here, but I was originally very nerdy about all the engineering aspects of it. And then I got into art photography, and then I became a scientist, and I brought it all together somehow to, you know, take images of the moon and Mercury and asteroids from spacecraft. And I think that, you know, mixing those different interests somehow, hope positively, affects the end product.
Mhm.
So I think for me, similar to Mark, it was probably around when I was 9 years old. I remember I got a gift subscription to Astronomy magazine, and I think it was right when the Voyager images of solar system planets came out. So there's Jupiter, Saturn, and Uranus and Neptune, and they just blew my mind. And I think that put me on a path to following astronomy. And then beyond that, when I was in college, the first image of the Pillars of Creation from Hubble, that one really just blew my mind, right? That was like, I remember sitting there looking at that image and just thinking, like, how is that even real? How can we possibly get those colors and these shapes in space? It was just incredible. And I had to understand how it was made. And then ultimately it became my job, which is pretty cool.
Yeah, I definitely remember the Pillars of Creation. And I kind of was growing up as the Hubble Heritage Project was kicking off. And it's kind of interesting looking back on that like this idea of like the modern like space image as this highly kind of saturated, really aesthetically pleasing image was really kind of started around that Hubble Heritage Project. So my whole experience of space has been filled with those images, and I'm always so curious what my conception of space would have been had I grown up, 10 or 20 years earlier and not had access to those types of images. And it could be quite different.
Mhm. Wow, I'm trying to remember the image that was first, and I can't. I can't remember a time that I wasn't fascinated by this, but it must have been, I was 10 years old when Cosmos was first aired in 1980. And that show completely determined the rest of my life. I like to say that it made me an art historian as well as someone who was deeply interested in the sciences, because that show was always invested in not just astronomical imagery, but Carl Sagan is always sitting in rare book libraries on that show. The show is full of art galleries and rare book libraries, and it completely connected the humanities with astronomy and with all the other sciences. And so that's where I got this crazy idea that there's no separation between these kinds of knowledge. But I would say that still for me, I think what is the image is actually, it's a part of a film that has had the most impact on me is the opening scene of Contact, which is directed by Carl Sagan and Andrian, or written by Carl Sagan and Andrian. And that's where we're on the Earth and the camera takes us up off the Earth and out, looking at it recede in space. And as we do, we're entering we're passing through the sphere of historical radio transmissions from the Earth. So as you get it further and further, you're listening to earlier and earlier radio transmissions as they're moving out, into space. And eventually you hit the 30s, and then everything just goes silent. And the camera takes us all the way out, into I'm not sure how far out it goes, but it's many, many galaxies out. And that was a really outstanding way to convey a certain loneliness of the Earth in the universe, and also just to get the scale across of the distances across which all of our information about space has to travel. So.
Amazing. Thank you so much all for sharing. I think we're now going to transition to some of our audience questions. So first question that I can see here is, what images seem to impact the public the most? And what do you think it is about those images that capture people's attention?
I can clearly say that whenever we do a Hubble press release about solar system objects, that always just takes off. People love the solar system. And it's going to be the 35th anniversary of Hubble this month, and we've got a nice package of images coming out. So stay tuned for that. But yeah, solar system objects, Mars, asteroids, things like that, like anything that's kind of near to us seems to capture people's interests immediately.
And the the first image of a black hole, and the second image of a black hole, people that was an incredible achievement. I would argue one of the greatest technological achievements of our species, and that is people are still talking about it to this day. And also anything to do with the search for extraterrestrial life is a hot topic with the public.
And for LROC, around the moon, we get our biggest hits whenever we release a picture, like we've just done that in the last couple of weeks, of a new vehicle landing on the moon. Blue Ghost landed on the moon on March 2nd. IM-2 attempted to land on the moon. It had sort of well, it landed, but it hit a little bit hard and tipped over. But we were able to get pictures of these vehicles on the surface, very soon after they land. And of course, when we returned our first pictures of the Apollo landing sites, where you could actually see the tracks that the astronauts left behind, our web hits went off the charts, right? And when there's an anniversary of the landing sites, we publish the latest image, and those are always the most popular. I understand why. It's pretty amazing that humans actually walked on the moon, and maybe they will sometime in my lifetime. I'm not sure about that, but we'll see. But those are always a big interest, even more so than some of what I think are more spectacular pictures of landscapes and sceneries on the scenery of the moon.
Yeah, these are all wonderful. So thinking more about images and ways that the public might interact with them or view them. I'm going to ask another audience question. Is there an astronomical image and an art object that you would particularly like to see brought together in a museum setting where you think there would be an exciting dialogue? Professor Roberts, do you want to jump in?
Sure.
Like a question. I would need to think about that a little bit.
That comes to mind.
Well, that's something I've wanted to do, and I was trying to work with this conceptual art historian Ron Jones. I don't know if anybody recognizes his name or not. Back about 5 or 6 years ago, and then unfortunately he had an untimely death, and so that project kind of died off. But it was putting side by side photos that were taken of the westward exploration in the United States in the 18th century. When you get these crazy guys that had glass plate negatives that are being carried around on a donkey, right? And they had to treat the negatives, wet plate, take the picture, while I'm sure everybody's familiar with that process, right? Because it's just it reminds me so much of what we do, the amount of work and planning that goes into just getting a single picture. And, that goes back to what I was talking about in the very beginning here, is that I just, I'm steeped in it, so I'm biased, right? But I think there's a lot of parallels between, that early landscape photography and what's being done out in space from, orbital and flyby assets. See, there I am jumping into engineering, calling the spacecraft an asset. But
Perfect. That's similar to almost what I was thinking. There was an exhibit in the Smithsonian Art Museum that kind of reframed some of the old romantic Hudson River School paintings as in the context of thinking a little more critically about the westward expansion, that those images kind of glamorized or romanticized. And I would love to see an exhibit that shows those images, those paintings again, next to modern Hubble and Webb images, because I know there's been lots of inspiration on the frontier of space and how it's presented in a kind of a similar way as a landscape. And I think there could be a lot of really interesting conversations to have in an exhibit hall that has you know, Hudson River School on one wall and Hubble images on the other.
Yeah, I think that's a great idea, just to really put them together and have people think about how much Hubble imagery is drawing on those precedents. And maybe another possibility would be to think about other kinds of precedents that we could put together with space imaging. Something that just pops to mind because it happened in class today is also other ways of showing how space imaging relates to the visual arts in general. And one of the ways that it does is that the kind of remote imaging and imaging outside of the visual spectrum that's developed in astronomy. So what astronomers have to do to be able to see things that are invisible and outside of the visible spectrum, all the technology that's developed in astronomy has now been turned back into the art world because it's the same kind of imaging that's used in paintings conservation. So today I was in a paintings conservation lab, and we went into a room and drew the curtains and turned off the lights and turned on UV light onto the painting to see how that object responded to this sort of probing with a certain kind of radiation. And it's remarkable to think about the way what we've had to do to be able to see in space has helped us see things on Earth as well. And it's given even the most familiar paintings, for example, a very strange new appearance. Like when you look at something in the infrared or in the ultraviolet, the painting itself changes, and you get a feel for the way what we see is such a sort of narrow window on the reality, that every object is sort of living in this spectral world and responding to different wavelengths in ways that can be very alien and strange to us. So it's not just outer space that's strange. We're surrounded by objects that are very strange if we just look at them through astronomical tools, including in art museums.
I guess
Thank you for your someone else want to
sorry,
jump in?
I just wanted to throw out when Jennifer was talking about paintings, off the top of my head, combining something like Vincent van Gogh's Starry Night with a Hubble Space Telescope of Andromeda or something like that would be quite an interesting, would spark an interesting dialogue in a museum setting. This is off the top of my head.
I sent a request to share. I don't know if that's possible, but one example of something that I've done for presentations is this comparison between a web image of 30 Doradus, torrential nebula, compared to this painting of from Caravaggio of Judith beheading Holofernes. And I feel like there's a lot of connections between, some of the web imagery and like old masters Renaissance paintings, and that's kind of the point of this part of the presentation when I give it. But this particular pairing just blows my mind. It's the tonality of the painting, the colors, even the shapes throughout both. Really, it's almost the universe is echoing art, or art is echoing the universe. Mm-hmm. They feed off of each other. It's fascinating.
Mm-hmm.
I think
that's a great comparison.
The orientation too, because I mean, of course, in space there is no up and down, and so how do we decide which way to orient this? And it's interesting if you look at the parallels between that and something like how we generally conceive of or are used to seeing certain conventions of art.
Mm-hmm.
Yeah,
and it also shows that you can get well beyond the typical Hudson River Western expansion landscape and still be in painting. And it helps, I think this is a great comparison because it helps people understand that there are different kinds of metaphors that you bring to space imaging based on the kinds of images you've seen in the past that might relate to it. I also have shown in the past a beautiful Hubble image of Jupiter and its moon Europa next to Titian's painting of the Rape of Europa. But two images that show Jupiter and Europa, and they actually have really a remarkable very similar palette, similar paint handling. Jupiter's red spot looks just like Europa's red scarf. So there's all kinds of visual connections, but the other connection is that, the arts and the humanities are sort of already out in space. We've already named everything in space based on our own visual and literary histories, that these characters are out there. And it's just one of many exercises you could do. You could just put even the same image against 10 different paintings and you'd have 10 different understandings of outer space.
Amazing, thank you. I really wish that we could continue this conversation for hours, but I think we only have time for one more audience question, and it's ending on sort of a future note. So how will astronomical imaging evolve in the future, both technologically and aesthetically?
Well, I'll jump in. I think the holy grail of astronomical imaging right now is looking far ahead to the Habitable Worlds Observatory, which the goal of that is to look at extrasolar planets around another star and be able to actually image a planet around another star.
Gonna say that as well. This is something I'm thinking a lot about. As an artist who I did lots of astrobiology for my scientific research, and this has been a question that's just been plaguing me, is like, how are we going to prepare for that kind of life detection moment visually? How do we convey a biosignature, which might be in the form of a spectra or a spectrum, where it is just kind of some noisy data that we fit a model to, and then there's some scientific agreement of what it's saying, but then we have this profound discovery that is just a graph, and how are we going to kind of visualize that in an equally profound way for the public? And that's a really hard question that I hope Habitable Worlds Observatory takes its time getting built, so I can come up with a solid routine, a solid plan for that.
I think a good follow-up to that is artists' impressions will probably get more scientifically accurate. Not to imply that they're not now, but for habitable worlds, we're probably still very, very far away from actually photographing these exoplanets in actual detail. But if we have enough information from the data we get about these exoplanets, then we could actually get artists to create very scientifically accurate impressions of what we think these habitable worlds, potentially habitable worlds, could look like.
I would say something interesting about a habitable world discovery, like suppose there is a biosignature that seems credible. It becomes even more important that that image also conveys our orientation, our spatial orientation to the target, the target area, so that we understand how far away this life is and how we relate to it. I think that's one of the places where I'm concerned about the difficulty of conveying scale. Because a lot of people's images of space, I think, are too proximate. And so when we have people being, worrying about alien invasion, for example, the chances are they aren't actually thinking about how far away any actual life might be out there. Just the sheer distance might mean that we can know about life on another planet, but the chance it's quite possible that at this point, whatever life was there when the light left that space has disappeared. It's not possible to communicate with what we're seeing. So having a life detection really raises for me some very fundamental ethical questions around scale, and that's a really essential part of what we would communicate about this. Whether it can be done visually, I don't know. That's up to Joe.
I'll do my best.
Yeah. Okay, so this has been such a wonderful discussion. I think we're out of time for today, but what a really eye-opening conversation. We really appreciate our stellar lineup of panelists. no pun intended, and their deeply insightful contributions, as well as all of you who took time out of your day to tune into our conversation and ask great questions. Have a great week, everyone.
Thank you all.
Thank you,
Thank
Meredith
you.
and Ariel. Thanks.
Thanks, everybody. Bye.